Hello everyone, I'm Shreya from Sri Venkateshwara College of Engineering, studying in third sem, Department of Electronics and Communication. Now I'm going to discuss about a topic in network analysis, that is superposition theorem. Firstly, introduction to superposition theorem. Superposition theorem is a powerful tool used in electrical circuit analysis. It allows us to solve complex circuits by breaking down into simpler parts. The theorem states that the response in any branch of a linear circuit is equal to the algebraic sum of responses caused by each independent sources acting alone while all other independent sources are turned off. Understanding linear circuits. Linear circuits have components that follow linear relationship between voltage, current, and resistance. Components such as resistors, capacitors, and inductors can be considered linear. Nonlinear components like diodes and transistors do not follow linear relationship and are not suitable for superposition analysis. Steps to applying superposition theorem. Turn off all independent sources except one, replacing them with their internal resistance. Short circuited for voltage sources and open circuited for current sources. Analyze the circuit and calculate the response caused by the one active source. Repeat the process for each. Consideration for applying superposition theorem. Superposition theorem can only be applied to linear circuits. It assumes that the circuit elements are passive, meaning they don't generate energy. The linearity assumption implies that the response caused by each independent source is directly proportional to the magnitude of the source. Example circuit. To illustrate the superposition theorem, let's consider a simple circuit with two voltage sources, V1 and V2, two resistors, that is R1 and R2. V1 is connected to series with R1 and V2 is connected in parallel with R2. We want to find the voltage across R2 using superposition theorem. Step 1. Analyzing V1 alone. In step 1, we consider V2 as an inactive or zero source. We calculate the voltage across R2 by treating V1 as the only active source in the circuit. We can use Ohm's law to determine the current flowing through R2 and then calculate the voltage drop across it. Step 2. Analyzing V2 alone. In step 2, we consider V1 as an inactive or zero source. We calculate the voltage across R2 by treating V2 as the only active source in the circuit. Again, using Ohm's law, we determine the current flowing through R2 and calculate the voltage drop across it. Step 3. Superposition. In step 3, we combine the result from step 1 and step 2 to obtain the total voltage across R2. Since the superposition theorem states that the total response is the sum of responses caused by each individual sources, we add the voltages obtained in step 1 and step 2. Calculation example. Let's consider V1 is equals to 5V and V2 is equals to 10V and R1 is equals to 2 ohms and R2 is equals to 4 ohms for our example circuit. In step 1, we find that the voltage across R2 caused by V1 alone is 10 volts, and in step 2, we find that voltage across R2 caused by V2 alone is 5 volts. Finally, in step 3, we add the voltages obtained in step 1 and step 2. The total voltage across R2 considering both V1 and V2 is 10 volts plus 5 volts, that is 15 volts. Therefore, superposition theorem tells us that the voltage across R2 in our example is 15 volts. Advantages of using superposition theorem. Superposition theorem simplifies complex circuits by breaking them down into smaller, manageable parts. It allows for easy calculation of individual responses caused by each independent source. By focusing on one source at a time, it helps in understanding the effect of each source on the overall circuit behavior. Limitations of superposition theorem. Superposition theorem cannot be used for circuits with dependent source. It can only be used to determine voltages and currents at specific points in the circuit, not the overall power consumption. The technique that became tedious and time consuming for circuit with a large number of sources. Real world applications. Superposition theorem finds application in various fields such as electrical power system, telecommunications, and electronic circuit design. It helps in the analysis and design of complex circuits, allowing engineers to optimize performance and troubleshoot issues. The theorem is also used in signal processing and control system to understand the behavior of linear system. Summary and conclusion. Superposition theorem is a valuable tool in electrical circuit analysis. It simplifies complex circuit by breaking them into smaller parts. By analyzing the response caused by each independent source separately and adding them up, we can find the total response of the circuit. Thank you.